Alright, welcome everyone to the penultimate lecture of the term. We're going to cover meta-analyses and talk about a little bit how to interpret them and how they are useful to you in the field. So sit back, enjoy, and hopefully you'll pick up a little something along the way. Talk to you in a bit. Alright, boiling it all down, right? So that's what meta-analyses are all about. Historically speaking, as we've talked about, replication is kind of the key to science, right? So if we do one study, and I'll keep using my theme lately of direct instruction, right? So if we do one study on direct instruction, that's great, but we're not convinced that it's effective. We do another study, and that's great, and so on and so forth, and we keep repeating, and what we start to find out is that under certain conditions, direct instruction is unbelievably effective. In other conditions, maybe not so. And we just go over and over and over, and we get this big batch of research. So we're talking hundreds of studies, right? So imagine if you're wanting to give advice to a school district or to a teacher or to a parent or something on these educational practices, and say, are you actually going to sit down and read an exhaustive list of the research? And are you going to cover are you going to spend the time to look for and get and then read and evaluate each and every study that's out there on direct instruction? The answer is probably not. It's just way too overwhelming. So we need a tool and to be able to do that for us, and that tool is meta-analysis. So ultimately what we're going to do is we're going to use meta-analytic study is a study that looks at all the other studies on a given topic and boils down the results into one article for you. Now, it's not just a summary of those results. There's actually some statistical technique that's going on, so you can actually interpret some of this stuff. And the reason that it's not just a list of saying, okay, this author found this author found this, and this author found X, is because not all studies are going to use the same metric, right? So we need to be able to standardize that stuff, right, in order to be able to compare apples to apples, because we've got one study that's looking at direct instruction for, what do you call it, a particular grade, like a second grade. You got another study that's looking at DI for the third grade. You got another study that's looking at reading, another study that's looking at math, and so on and so forth. And you've got all these different things. And the answer is we can't compare all those studies across to each other, because, on the surface anyway, because they're different topics. They're different independent variables, they're different dependent variables, they're different age groups, and all this stuff. So at this point, they're apples and oranges. So we standardize those, and just like what we talked about previously with Z-scores and being able to standardize intelligence scores and things like that. So we're going to do that with the actual study as a whole, right? So we're going to take this one study published by so-and-so in 1994 and standardize that and compare that to another study that was published in 1996 by a different set of authors using a slightly different technique. So with that standardization practice is what allows us to look at that field in one big shot, and that's what gets published. That's what you read when you grab a meta-analytic study. You're reviewing all those things that have been standardized. Well, what do we standardize? We use the effect size, right? So I can't compare the means from one study to another study. There's the apples and oranges thing, but we can compare effect size, right? So because the effect size is essentially a standardized measure of the differences in your groups, or the effectiveness of your independent variable. So essentially, as I just said, it's basically standardized means and standardized standard deviations. Yeah, exactly. It gets a little confusing, but the point is that we're just going to put them all on the same scale, and we can then use that effect size and get average effect sizes and stuff like that. So we'll get into that in a second, because that's going to give us our big picture. So, all right, let's move on. How do they do this? Well, first off, you choose a topic. Right? You can choose a very broad topic, DI, or a very narrow topic, DI for reading, interventions at the second grade level, okay? Or tier 2, tier 3 level DI, that type of stuff. So you can just really narrow it down if you want, or you can start broad. It's up to you. It's up to each author. They're going to do whatever their interest is. I've had my one of my studies reviewed many times for several different meta-analytic studies, and they're always looking at slightly different things. The study that I'm referring to is an evaluation of threaded discussions in the college classroom and using internet stuff to help support a face-to-face class, right? So some people were looking at just online technologies in general. Other people were looking specifically at threaded discussion or listservs or discussion forums on like Blackboard, and they were looking at the effectiveness of that stuff. So my study got chosen for both of those. So one was broad and one was narrow. So it's just up to each person, right, that wants to do the topic. And then you do the hard part, right, the lit review. Okay? This has to be exhaustive. Right? So imagine going to psyc514 or something like that, which covers thousands of journals, not just journal articles, thousands of different journals that are published on probably a quarterly basis, at least semi-annually, if not quarterly, for the last, 100 and some odd years. Well, my gosh, there's a lot of information out there. So when I said hundreds of articles earlier, it's probably more like thousands. So then you have to just start narrowing it down. What type of study do you want? And we'll get to that in a second. That's about methodology stuff. But so you do this lit review. You find all the particular articles that are relevant on your topic using keyword searches and things like that. Right? Part of the thing that you're going to run into, or that these authors run into, is that you'll find in psyc5 the abstract about somebody's dissertation. Right? But you won't find the actual dissertation because that's copyrighted and owned by the university where you went to school at and did your doctoral work. So it's not published in a journal. And oftentimes dissertations aren't published anywhere. Sometimes they are, but usually they're not. You just it kind of hangs out there in la la land. Well, how are you going to find that non-published dissertation? It's a relevant study on the topic at hand, and you want to include it in your meta-analysis because it's a high-quality study. But how are you going to get it? You might have to pay for it, right? You might have to order that from the university. You may have to contact the author directly, if you can even find it, right? So this is really one of the more challenging parts of doing a meta-analysis, is finding all these studies, right? And then getting that information out of the studies. And what do you include? Which one? You've got thousands of journal articles that are covering DI. Which ones do you want? You have to choose. And the authors of the meta-analysis, when you're reading them, they'll tell you what they chose, and they'll tell you their inclusion criteria, right? So their inclusion criteria may be something like it had to be experimental, no correlational stuff, or no quasi-experimental data was included in this meta-analysis. So then they take their thousands of articles, and they go through, excuse me, I hate it when I do that. I take their thousands of articles and go through and drop the ones that don't meet their basic criteria. So, did they have a directly observed metric for their dependent measure? Maybe that's a criteria. Did they have purely experimental results, randomized experimental trials? Maybe, that type of thing. So you go through and you choose all that stuff that you want, and then you start boiling down those thousands of articles into hundreds of articles, and then maybe 50 articles or 60 articles or 20, and oftentimes it gets down to where it's 10 or 15, and that's one of those narrow sort of areas where you're looking at 10 or 15 major studies in the field that meet the criteria that you're after, and you're going to review all those. But I've seen others that cover 50 or 60 in their final analysis that got selected. Right? Okay, so once we've chosen the articles that need to be in or that are going to be in the meta-analysis, then we need to code the data. The basic idea here is we have to code pretty much everything. And we have to code this in a way that allows us to, once again, standardize across these things. So we're going to take the dependent variables. Did we use reading fluency as a measure? All right, well, reading fluency gets a 1. Words read correctly per minute maybe gets maybe that's the measure of reading fluency. So anything that has that gets a 1. And something else that, maybe a grade level on some particular probe for reading, maybe that gets a 2, right? So then we can say all articles that were coded with a 1, or all articles that had a 1 are in this category, all articles that had a 2 are in another category. So again, we can start to look at those different measures that were there in sort of a table, if you will. We say, okay, what was the effect size for the ones that had this dependent variable? What were the effect size for ones that had this type of dependent variable? So we code everything. Independent variables, was it randomized? Was it not randomized? What type of IV was it that we're focusing on the DI stuff still? Was it SRA's reading mastery, or was it somebody else's stuff? Who knows? So we're going to code all that stuff to make sure that it's all entered in there, and we can filter by those different types and different topics if we want. And then we go through and compute effect sizes. Okay? So again, dependent variables by themselves are not standardized, so we need to standardize those across everything. So we're going to look at that effect size, which essentially is Cohen's, which most often is used for this is Cohen's d, which is the mean minus the mean divided by the pooled standard deviation of both of them. All right, so both means from the pre-test, post-test data, if you will, or group 1 times group 1 compared to group 2, however you want to look at that. That's going to give us our effect size. Cohen's d is a measure of effect sizes we've talked about. So that's how we're going to do that. The other thing we can do is get the odds ratio. Is odds that given one level of the independent variable, you have a given outcome. In other words, you have a given level of a dependent variable. So what's the odds that if you receive this, you will be at X later on for the dv? So the odds ratio is probably, in school psych literature, I've seen the odds ratio used more often than Cohen's d. I'm not sure why. Your book talks a little bit about odds ratios and Cohen's d, and it kind of weights Cohen's d a little bit. In my opinion, my reading of it, it kind of weighted Cohen's d a little heavier than odds ratios. But lately in the literature, the last year or so, I've been seeing a lot of odds ratios out there in the school psych stuff, meta-analyses. So they're both valid measures. They're both standardized measures. It allows you to compare all these studies across each other. All right, so once we do that, it gets really straightforward, right? So we're going to calculate the effect sizes for each and every study. Then we're going to calculate or do the odds ratios for each and every study, whichever way you want to look at it. Then all we're going to do is average the effect sizes. That's it. Just take all those let's say you got 50 studies. We're going to have 50 different effect sizes. Average them. Was it low, medium, or high? So now we can make a general statement saying that across these 50 studies, direct instruction had a high effect size on average. Okay, that's a pretty good way to summarize all the data, right? We also report the standard errors of those effect sizes, so we can get an estimate of how much range there was. You know, if we had a medium effect size with a huge standard error, meaning there were some that had no effect and some that had a lot of effect, or a big effect, then we would be less confident in the findings. Or if we had, like DI does, a high effect size with very small standard errors, then we would be really confident that this is a very powerful intervention because it works across the board. Okay. Other things we can do, we can weight the results. Right? Studies, and this gets a little bit more complicated in terms of running the analyses, but I think it gives you a little bit more information. It's probably more useful for the reader and the consumer of this information. So what we're going to do is we're going to take studies that have a higher sample size are given higher weights, right? And studies with higher validity are given higher weights. Right? This makes the results of the meta-analysis more sensitive to real effects and decrease bias. For example, if we've got a study, if all studies are rated equally and weighted equally, I should say, then the study that has the small sample size and low validity, let's say, is given just as much power as a study that has a big sample size and highly valid, well-controlled research. Well, that's kind of a bastardization of what we know about research, right? That all designs are not created equal, so why are we treating them equally when it comes to looking at effect sizes? And, well, we don't have to. We can weight those things. So those are typically the two ways in which we weight them. There's other ways to weight these things, but those are by far the most common because they're objective. There's some subjective stuff that you could do with weighting, but people tend to argue against that. So what's the point, right? The whole point behind weighting these things is to make them more objective or make the results more objective, so let's not use subjective criteria. Then we're going to ask the question, are the effect sizes functionally random? If the answer is no, if those effect sizes are not random, which is essentially what we would hope, then we need to explain what is causing that difference. Probably going to be the independent variable, right? So or some type of confound, but it's most likely going to be the independent variable because, again, you had all these effect sizes, and hopefully they were not random. If they are random, then basically we're saying, well, heck, we don't really know what's going on with this field at all right? And it ends up with messy data, so to speak, where we're not sure what the effect of some intervention is on people overall. Right? But we're going to come to a bias that happens here in a little bit, that we typically don't get that finding, right? Or why we did, that causes the fact that we don't get that finding. Right? Oftentimes we get multiple dependent measures in a particular study. Well, that means you're going to have multiple effect sizes because we do an effect size for each dependent measure, right? So then we just average out all those effect sizes for each study, and then we average the averages and blah, blah, blah. You get the idea there. So it's pretty straightforward. It's time-consuming in the sense that you have to gather a lot of data about the data that's already out there, and then enter it and analyze it and code it and make sure that you're selecting variables properly for your coding analysis and all those things, and how you're analyzing your data. But generally speaking, it's not a highly complex sort of thing. It's just essentially calculating an effect size, which is means, the mean minus the mean divided by an error term. And then we're just getting averages of all those things. So it's really straightforward. All right, publication bias. In my opinion, this is by far the biggest issue in meta-analysis. It's because we're focusing on published studies, right? So only the studies that are significant are typically speaking, only studies that are significant are published. So what happens to all those dozens of articles, hundreds of articles, thousands of articles that tried to implement the independent variable but were unsuccessful and did not get the significant differences? Well, they're likely not going to be included in your meta-analysis. So do we have a natural bias here? Oh yeah, and it's called the publication bias. So we have to ask the question, why did the other ones get rejected? We don't always know the answer to this, by the way. This gets very difficult to do, right? So why did the other studies get rejected? Was it bad science? Did they have piss-poor methodology? Did they not have any, was their validity so low that no one wanted to publish this article independent of their results? If that's the case, then not including them in the meta-analysis is fine. However, what often happens is this pressure to publish thing, and the public journal reviewers typically like to publish stuff that has significant results. So what happens if you didn't get significant results, but you have high validity and you have a good sample size and you have all those things, but it never got published because it wasn't significant? Well, now it's not being included, but that is something that really should be included. This would be, for example, direct instruction. If there was evidence out there saying that it was ineffective and we couldn't get good results with it, that likely wouldn't be published, at least not in your mainstream journals, and as a result, you're never going to include it in the meta-analysis. So you're going to have this positive bias, or this publication bias, in meta-analyses. So we have to take some of these with a grain of salt, and you have to be aware of the fact that there is some natural bias in here. Essentially, the conclusion of what happens with publication bias is just an overinflation of effect. And that effect is at the population level. We'll likely conclude that this intervention, or whatever it is, will work at the population level, when in reality it might not, because there may have been a lot of studies that were done that never got published that showed that it wasn't effective. Now, that said, people are well aware of publication bias, so in the last, decade or so, there's been a lot more sensitivity to making sure that journals publish articles that are good science. So the science is done well, right? But didn't get significant results, because not figuring out that something doesn't work is just as important as figuring out that something does. So people realize that, and I think that there's this trend in probably the last 10 years to do more publication along those lines. But that said, it's still very limited. I've been rejected from multiple studies, or multiple journals, just because I didn't get significant results when I didn't actually expect significant results. The literature's basically added up, said, no, I shouldn't get any. And so I made my hypothesis that, no, I was not going to get significant results. And then write up the article, submitted, it gets rejected because you didn't get significant results. Well, really, that's exactly what I predicted. That's what should have happened. That's informative information. It's very informative, and it doesn't get published. And it's like, oh, well, that's just the way it goes. And I just hope that it continues to change and we can start to actually report some of this stuff. And there's a journal out there called the Journal of Null Results, which is all about publishing articles that didn't produce the findings that were anticipated, or didn't produce significant results, but had really high validity. So it's an important journal article or a journal to cover. My personal opinion is they should probably donate a section from every publication, so every quarter or however often they're releasing it, to studies that did not get the results that were intended. However, they were highly valid studies. That's my opinion. I think that's one way that we could start to reduce publication bias. But I'm not in any position of power to control that, so it's just me sitting here talking to a computer and espousing ideas that hopefully someone will eventually hear. All right, last thing. Meta-analyses are functionally correlational. Don't forget that. All right? They are correlational in nature. Sure, you're looking at scientific data and you're looking at stuff that may have been experimentally manipulated, But the meta-analysis itself, there's no random assignment or to the meta-analytic condition. There's no condition to be had. So just remember that there is a bit of correlation going on here, and we're not really talking about pure causal stuff. We're just talking about a descriptive overview of the field. That's it. It's just basically descriptive statistics. And always, 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 what was chosen for inclusion? Why did they choose those particular things? Why that topic? Why that procedure? Why those 10 studies versus the other 10 that are out there on the same topic? So be cautious with that. Don't forget the publication bias. Don't forget the stuff about dissertations, not being able to find those or get access to those, and that type of stuff. All right. Well, I hope you know a little bit about meta-analysis now, and we'll talk again soon.